All right, so based on what we have covered so far, which polysaccharide or which macromolecule of alpha 1,4 glycosidic bonds? Anybody?
Starch.
Starch. Specifically, which one in starch? Which one? So starch as it, but so starch is made up of two macromolecules, right? Which two macromolecules make up? So starch itself is a macromolecule, but which two make it up? The two A word.
Amylose and amylopectin,
Right. So starch, which include those two. Any other one apart from starch? What about glycogen? So both glycogen and starch as a mixture of 1,4 and something else, but we will get there. Which one has beta 1,4?
cellulose.
Right? All right, so let's just say 1, 2. Which one has 1, 2?
Sucrose.
Sucrose. The reason why I have alpha 1 and beta 2, the alpha is from the glucose. So we are using alpha glucose and the beta version of fructose. So it's carbon 2 of beta fructose. That's why I put beta 2. So if you're asked to be specific, it is alpha 1, beta 2. All right, which one is alpha? I should put alpha. Alpha 1,6.
Amylopectin.
Right, which is a part of the general term, as in the general one, right? Starch, as well as glycogen again. So both starch and glycogen as a mixture of 1,4 and 1,6. So the straight chain is the 1,4, and when we have the branch, it occurs at 1,6. So these supposed to be like common knowledge. You know the type of bond and the macromolecule it is involved in forming.
Sorry, so that one is in the straight chain, it's 1,4?
Yeah. So, right. The 1,6 comes about when it is forming the branch. So both starch and glycogen are branched. So tomorrow, apart from doing phospholipid, we're going to relate structure to function. All right, so number 2 now, which molecule is this here? Number 1, as in I. What is 2I?
Sir, beta glucose.
Right. And how we know it is beta again?
Because the OH go.
The OH and carbon, number 1, right? And this molecule over here is?
Alpha fructose.
Right. This polymer down here, what is it? Anybody can tell me? 3A. What is 3A? Nobody knows. All right. When you look, if you want to look at, yeah, go,
Hello, sir.
please repeat.
Amylose.
When you look at the glucose, what is happening to this? Are all of them upright? So this is
flipped.
right. So this is carbon 6, right? This is carbon 6, and this is carbon 6. So each of them is flipping one after the next. So which polymer do we know do that? Where they rotate 180 degrees.
Cellulose.
Right. So this is carbon 6, and we see that it flip, or we say it rotates 180 degrees Celsius. Well, that's the term that we use. So the molecules rotate 180 degrees, in both degrees Celsius, like a temperature. They rotate 180 degrees. So once you see that happening, it only happens in cellulose. And you don't have to use carbon 6 either. You can use the glycosidic bond. Here it is pointing up, but here it is pointing downwards. So you can use carbon 6, or you can use the glycosidic bond. And again, details are not important when it comes to these structures. So we can leave out a lot of the details. In terms, and details, I mean the OH and the H's. All right, this molecule down here.
Sir, wait, before you move on, I have a question.
Sure.
So like how it's a 1, 4, wouldn't it have to be like 1, 4 on each?
All right. So this first glucose, right? This would be carbon 1. Just a second. This would be carbon 1, right?
Okay.
And if you look at this now, if this is carbon 6, as in here, this is carbon 5, right? And this is carbon 4, 3, 2, 1. So carbon 1 is in line with 4. Was that what you're asking? If
Wait, not really.
All right, ask it again.
Wait, the 1, 4 is all right. It's like how you have 4 carbon, like the ring structure.
Yeah.
No, wouldn't it have to be 4 ring structures instead, like joined together, or it can be like 3 and more?
Oh, that I mean, as in the amount of glucose that we draw?
Yeah.
Oh, at least 3. Because with the 3, we get to see that the molecules rotate 180. So it needs at least 3 of them.
Oh, okay.
Yeah, because we see that this one it point up and the next one it point downwards. Yes, so we can see the 180 degrees rotation. Yeah. All right. So this one down here now would be all right. Before you answer, how many types of glycosidic bonds are present? As in, like over here, hold on, where you have 1, 4, 1, 2, 1, 6. Which of these over here? What is happening to how many of these type of bonds is present in this molecule down here? All right, which bond is this? Is it 1, 2, 1, 4? 1,6. What is it?
Sir, 1,6.
This one that I circle here? It would be one. All right, so look, where you have the oxygen, the carbon next to oxygen is always carbon 1. So this carbon here, it is always carbon 1. So this would be carbon, right? Now, if this is always carbon 1, and remember, this one up here is carbon 6. So here, we have it coming off carbon 1, and this is carbon 6. So we have 1, 4, as well as 1, 6 here. So we know that starch has both 1, 4 and 1, 6, and glycogen also have 1, 4 and 1, 6.
So why is it?
Go
Where
ahead.
the 4 from?
Where the
Because
4?
I know, yeah. Is it because on the other molecule it would be 1, 2? Oh, never mind. Never mind.
You're good?
Yes, sir.
All right. So the difference with starch and glycogen now, starch has 2 molecules, amylose and amylopectin. Amylose have just the 1, 4. Amylopectin has both the 1, 4 and the 1, 6. So for this, you could put that it is amylopectin, right? Or it could be glycogen. So in terms of it being starch, it would be the amylopectin portion of starch. So you could put either of these, amylopectin, and in bracket if you want to put starch. All right. So once you see 1, 4, all right. So once you see a straight chain, and then you have that linkage. So it's basically 2 straight chains with a connection. That is what is giving you a branch. So you have a chain up here of 1 to 4, and the next chain down here of 1 to 4. But the 2 chains are connected by a 1 to 6 bond. All right, so we're good with this part now? All right, so if you remember, the polysaccharides are not the only macromolecules. So, and also I told you that you don't have to get the chemical structure of this, of a particular macromolecule, except for the polysaccharides. So based on this representation, which polysaccharide is this representing? Anybody want to answer? Let me see. Nadiv, is there? Would I?
I think.
All right. Yeah, go ahead, Nadiv.
I think it would be for fast and liquid.
Right. So it is, if you want to say fats, I can say lipid / triglyceride. Right. So if you see the term triglyceride, right? What is this rectangle, this straight rectangle? Alia, would I? What is this one represented here?
I don't remember.
All right, anybody remember? What would this represent?
Sir, the glass.
The glycerol?
Right.
No.
Yeah, glycerol. And what would the structure represent?
The
The
FA.
bonding.
The FA. And what is the FA?
Fatty acid.
That is correct. So remember, our triglyceride is tri because it is 3. So 3 fatty acid attached to a molecule of glycerol. So you're correct. So it is lipid. If you want to say fats, lipid triglyceride. So it is made up of a molecule of glycerol with 3 fatty acids. So that is what figure 1 is representing. So it says state the name of the compound. So you can put any of these names. But this is, well, yeah, any of them is good. And then label the parts. So you would put, so you can put fatty acid 1, 2, 3 add here and glycerol. Now, what would this one be?
Phospholipid.
Phospholipid. What wonderful. All right.
That last one.
Phospholipid. All right. Again, so this would still be what? This
The glycerol.
Right.
Then the little circle will be the phosphate group.
That's wonderful. All right. So this is the phosphate group.
Yeah, and then them two back they're going to be the fatty acid again.
Right. So the difference between the phospholipid and the triglyceride is that one of your fatty acid is replaced with a phosphate group. So part B now is asking for us to draw the chemical structure of the fatty acid, sorry, the triglyceride and the phospholipid. So remember, this is just a representation of it. So now I'm asking for the chemical structure. All right, which means I'm going to have to erase this part. So can I erase this part now?
Yes, yes, sir. Yes, sir.
All right. All right, how many carbons are in a molecule of glycerol?
3.
Right.
No.
And what should be on each carbon?
OH.
Right. But remember now, we're not showing how the triglyceride is formed, right? All we need to do is draw the structure, which means that what? It shouldn't have the OH. But since it's
have the OH then.
right, since it's a practice class, let us just look back at how it is produced. So this is your molecule of glycerol, which means we are going to need 3 fatty acids, right? What is a fatty acid again? How its structure?
Fatty acid.
Yeah. How is it set up? As in, which functional group is on it?
OH, COOH.
Right.
What you call it?
Yeah, the carboxylic acid.
Okay.
Right. So it's just a carboxylic group with a long hydrocarbon tail. So H, double bond O, right? And so instead of putting all of these C's, we can just use what instead of all of these C's and
It
H's.
does some stick up and stick down
Right.
something.
Yeah. So you can just do this. Right? And remember, where the two lines meet, what do they represent?
They represent carbon.
Right. So instead of drawing the carbon and the hydrogens, we can just do this. So we need 3 fatty acids, right? So what would happen now is that what? You're going to remove the OH.
The H2O, 2H,
right?
and yeah.
So you take the OH from the acid and the hydrogen from the glycerol. So if you should remove the OH from the acid and the H from the alcohol, it means that the oxygen of the glycerol would be connected to this carbon. So that is how the reaction happens. Remove the OH from the acid and the hydrogen from the carbon. So I'm going to move this up now and put it on the oxygen. So you would have this.
So after I remove the H2O, the H, what do you call it? The OH from the acid and the OH from
H from the alcohol.
And the H from the Maria, draw over about this, draw over about one new structure.
All right, so hold on. If you were showing, all right, hold on. Let me do it like this. Hold on. Just a second. Quickly. Oh, I'm pressing the wrong button. Sorry about that. Where was I? Right, this. So, in terms of the question, they ask you to draw the structure, right? Not show how it is formed. This, what I'm doing here now, is reminding you how it is formed. So you wouldn't do this in terms of this question, all right? Doing this would be showing them how it is produced. So just a second. Let me erase that, move this up. All right. So let us look back at how it is produced then. So we're going to need a second fatty acid. It don't have to be of the same length. All right. And we need a third one. And so for each of them, you are going to remove the OH from the acid and the H from the glycerol. All right, so remove OH and the H. And so what you will get as a result of that now, you draw back your 3 carbons. It will have on the H's, right? But will it still have OH here?
Sir, repeat the question.
I'm asking if it will still have OH.
No, no, sir. You're gonna just put the CO, the C double bond.
So just the O, right? Because we took off the H. And for the acid now, we took off the OH, right? Which means that all you're left with is C double bond O, because we took off the OH. So now this oxygen of glycerol is attached to the carbon with the double bond O. Everything else in the structure stays the same. I'm not counting up the carbons, by the way. I'm just doing it arbitrarily in this case. All right. And so this is the actual chemical structure of the triglyceride. All right. Where you draw all the atoms involved. So in terms of the question, you would just draw this structure, not doing this to give this, right? When you would do all of this is if it said, if it asks you to show.
To draw the formation.
Right, so if it asks you to show the formation. Triglyceride. So this is showing the formation. But if it just asks you to draw the triglyceride, then you just do this part here, which is simply to draw it. All right. So this part down here is what I was asking you to do. All right. Now, in terms of the phospholipid, as we said earlier, all you would do is what? Remove one of the fatty acid and add on a phosphate group. And as we know, phosphate is
PO4.
All right. And one of them must be a double bond O, and the rest single bond. And just put a negative charge on one of the oxygen with the single bond. All right. So this is your phospholipid. All right, moving on again. So it says, what is the name of the reaction you use to form OH?
Condensation or ester.
All right. You
No,
can put condensation.
All right.
Yeah. So condensation is correct. And then it asks us to circle the name and circle it. So what yeah, go ahead.
COOO.
All right.
With a double bond.
Yeah.
And O.
All right. And what is this one called?
Carboxylic. That's all?
As I said, the name, if it's not condensation, right? What's the other name?
We name some H.
No, man, not the opposite. As in, what is the next?
Something like that, sir?
No, man, she said it a while ago, man. Condensation or E. It starts with E.
Oh, esterification.
Yeah. Right. So what? So if it's esterification, you're going to get an ester bond. Yeah. So this bond here, it is called an ester bond. So because it's esterification, as I said, so if you put esterification or condensation, that's okay. All right. So this bond here, it's called an ester bond. So so in triglycerides, we have ester bond. In your polysaccharides or your disaccharides, what type of bond do we have? Start with G.
Glycosidic.
Right. So your polysaccharides have glycosidic bonds. Your triglycerides have ester bonds. All right. So next one now, it says name the reaction that occurs during the digestion of the compound in figure 1, which is our triglyceride. Just a second, are you writing this molecule or I can erase a portion of it? I want to draw back the triglyceride.
I'm finishing.
All right, so I'm going to change it back to the 3 fatty acids. All right, so as you had, Shanika, I think had said, to form this, it is condensation. Now, what happens in digestion?
Would get broken down, you know, that's all I
Right,
know.
all right. So, if it was your polysaccharide, right? Like a starch, or let's just say carbohydrate in general. Those complex sugars, what will they be broken down into?
They become more soluble, soluble sugars?
Yeah, but specifically no. All right, so what makes up carbohydrates or starch? Which which monosaccharide make up starch? As in, what do you join up to make starch? It's too simple. I think the answer is too simple. All right, what makes up sucrose?
So,
Yeah.
Glucose and fructose.
All right. So what makes up starch?
Glucose and fructose.
No, man. No, starch.
Starch?
Yeah. Just glucose, right?
Okay.
Yeah. So when you break down starch, what are you going to get?
Glucose.
Right. So you join up glucose to make starch. That means when you break down starch completely, you should get back what? The
Glucose.
Right. So just like if you break up sucrose, you should get back glucose and fructose. If you break up cellulose, you have to get glucose. If you break up glycogen, you get glucose because glucose makes up all of them. So with your triglycerides now, what compounds were used to form your triglyceride? Which two compounds? So yeah, go ahead.
Sorry, glycerol and fatty acids.
All right. How many fatty acids?
3.
Right. So when you digest fats, right? What should we get back? Okay, if you're not sure.
Wait, sir, repeat the 3 fatty acids.
So hold on. So up here, right? We just a second. Up here we have what? Glycerol and 3 fatty acids. And we combine them in a condensation reaction. All right. So we have condensation. And that is how we get triglyceride. So you said during digestion, right? We are breaking down these complex molecules into simpler ones. So condensation, we are joining simple molecules to form more complex one. What is the opposite of condensation?
Hydrolysis.
Right. Hydrolysis. So if condensation, you're forming triglyceride from glycerol and 3 fatty acids, what will hydrolysis do?
The reversible reaction.
Yeah, the opposite.
So what will you get if you hydrolyze the triglyceride?
You would get the glycerol and the fatty acids.
That is correct. And that is what happens in digestion. That is why they tell you the end product of the digestion of fats is what? From CSEC. They would tell you the end product of fat digestion is fatty acids and what?
Glycerol.
Exactly.
What? Glycerol.
Yeah.
My bad.
Right. Which is this reaction here. Right. So when I say name the reaction that occurs during the digestion of the compound, it would be hydrolysis. because we are breaking it down. So so remember, when you form this compound, right, which small molecule is also produced?
Water.
Right. How many, based on what you're seeing up here, how many water should we get?
3 water.
That is correct.
Oh my God.
Yeah. So in hydrolysis, we are introducing back the water. So we are putting on back the OH on the acid part and the hydrogen on the glycerol. That is why we can break it up back. All right. And for part F, when I say draw the molecules that would be formed after the digestion of the triglyceride, you should draw, what should you draw?
Glycerol or fatty acid.
Exactly. Because when you break up the triglyceride, you're going to get
back.
Exactly. Wonderful.
So just draw back the previous molecule. Okay.
Right. Mm-hmm. And that is that. Right. So A, anybody know which structure is A?
Amino acid.
Right. I'm not picking up the pen. Give me a second. Right, so A is amino acids, and it is used to produce what? What amino acids make up which macromolecule?
Protein.
Right. So the monomer is so monomer is the simple molecule that makes up the macromolecules. So amino acids make up protein. Which molecule is this one here?
Glycerol.
Right. And we know that glycerol is a part of which molecule? Which molecule is glycerol a part of?
Lipid.
Yeah. All right. This one now is which?
Glucose.
Specifically?
Alpha glucose.
Look at the OH. It is
beta glucose.
And if it's beta glucose, which macromolecule it forms?
I don't know.
I don't know. Let's start with C. Yeah, I'm going to start with C.
Cellulose.
Right. All right, and this one over here is which?
Alpha glucose.
All right. So it can be found in which macro molecules?
Starch.
It can be found in starch. Yes, sucrose is a disaccharide, so it's kind of simple. But there's a next polysaccharide, starch and a G word.
Glycogen.
Right. So remember, starch and glycogen is the alpha 1,4 and alpha 1,6. Cellulose is beta 1,4. All right, and this one up here, which
aqua.
Up here.
Oh, no, carboxylic group.
Right, which is, but for bio, we're not calling it a carboxylic acid. What do we call it?
Ester group.
As in the entire thing.
Fatty acid.
Right.
No.
Yeah, why not believe like gonna have memory loss? Yeah. I'm afraid to say something. Right. So, and we know that fatty acid is a part of which macromolecule?
Lipids.
Right. Because we know it and glycerol combine to form the lipids. All right, there you have it. So you should be able to know your monomer so you can know which polymer they will form. All right. Clear the screen or wait a little. Anybody writing? All right, I'm going to clear the screen now. So let's just do protein and wrap with that. Sorry. All right. Clear screen. So as we know, protein, I'm going to draw a structure of protein. All right, let me just revise how it is done. So as we know, which two groups are in proteins? Which two functional group? Sorry, not protein, amino acids. So amino acids have two functional groups. What are they? And this group, it is called the amine group. All right. And the COOH is the carboxyl group.
So amine?
Amine. We say amine.
Okay.
And the R group here, it represents the side group. Or sometimes we say side chain. So you can say side group or side chain. So R is to keep it simple. So R, it sometimes can be a ring structure. It can be two carbons with sulfur and so forth. So to keep it simple, we just use R. All right, to form the protein now, let's put some amino acids on the board. Remind me to invite Scott for tomorrow's class.
Okay, sir.
So we can practice on Wednesday and do content on Thursdays. All right.
Okay, sir.
Yeah.
Sorry, did you teach protein Camila, you know?
Yeah, not in our regular Friday class. So
Camila, what is?
yes, I first mega do it. But protein, it's simple, same man. A condensation reaction, so you don't need to worry. So all I'm doing is drawing. So you see the amino acid.
Something simple.
Very much simple. So amino acids, right? They differ in the R group. So they will have the NH2, the C double bond, as in the carboxyl group, the amine group. So for CAPE, what you will get, they will put R and they can put R prime to show that it is a different amino acid. All right. Let me draw next one. So every amino acid, they have their NH2 group and they have the COOH group. As we said, they differ in the R group. So we just put R double prime, R prime, and R to show that they are different amino acids. So amino acids differ in their R group. So again, if it's condensation, what should I do to join this amino acid to this one?
Remove H2O.
All right, so I'm going to take the OH from the acid.
The OH and the H from this too.
Wonderful. I'm going to do the same thing here. And so this will happen many times. So you get a long polypeptide. So with sugars, you get polysaccharides. With proteins, you get polypeptide. Because we are forming a you are getting a peptide bond. All right, so you join up 3. This is what you will get. Let me color code them back. So CrNH2. Sorry, why am I putting back the OH? No OH. So the OH is gone as well as this H. So this carbon is going to be connected to the nitrogen. So I'm going to get NH. Keep on up on the OH. All right. And then again, you will have NH, C, R double prime, H, wait, where am, yeah. And then C double bond O, OH. All right, but this OH, if you want to show that it continues, right? We know that this OH would come off to connect to a next nitrogen, right? And this hydrogen would also be used in a next reaction. So we can leave these free to show that it continues, all right? What we need to be able to do is identify our peptide bond, which is this bond, the C to N, the H and the O. This bond here, that is called our peptide bond. So if you get a segment of a polypeptide, you should be able to identify your peptide bond. So it is the carbon bonded to nitrogen. So we have a next one here as well. All right. So this is how we form the polypeptide. Of course, based on this, we would get 1 water here and the next one here. So 2 water. So question, when proteins are digested, they are broken down into what? So if we use amino
acid, sir.
right, because we join up amino acids to form protein. That means if you break down the protein, you are going to get back the monomer. So any polymer you have, right? So any polysaccharide, the fats and the protein, when they are broken down, they are going to give you the monomer. Whatever you join up to make the polymer, which is the macromolecule, when it is broken down, give me a next word. I don't want to use broken down. Which word can I use? Instead of saying broken down.
Condensed.
Not condensed.
Disintegrate. Disintegrate.
The H word.
Hydrolyze.
Right.
Yeah, that.
Because, so condense, remember, condense, we are removing the molecule of water so we can join them up, right? So to break it down, right, we have to introduce water, which means we are hydrolyzing it. All right. So let me just add as a little side note over here. To form macromolecules, we join monomers together by removing So anytime you are getting the monomer from the macromolecule, that is hydrolysis. So blue is hydrolysis. We're adding back water. So you would put in back water. Here you're taking out the water. That is condensation. So you join them up by taking out the water. For hydrolysis, you break it up by putting back in water. In this case, it would be 2 water if you want to be specific. All right. So tomorrow now, we're going to look at how all these structures influence their function. All right, so I'm going to end it here for tonight. So just keep on practicing to draw and study the different monomers and the reactions and their structure.